Hi students, let's solve this ninth problem. Show that each of the relation on set A, x belongs to z. Z means it's an integer, right? That is, you will not have fractions. It will only be numbers, complete numbers, like 1, 2, 3, 4. You will not have fractions. Now x belongs to integers, and that x is nothing but between 0 and 12, right? It's between 0 and 12. It's given by relation. Modulus of a minus b is a multiple of 4. This is one case. And second question is a is equal to b, right? Let's take the first case one. First one. So a is equal to, we can simply write this set, right? It will be 0 and between 0 and 12. So it will be 1, 2, 3 till 12, right? These are the integers. You can also have 0 here because it can be equal to, 0 can be equal to x. So you can have numbers including 0 because it is equal to here, right? And 12 also. So 0, 1, 2, 3 till 12. Now this is a set. Now what is relation? It should be modulus of a minus b should be a multiple of 4. What are the multiples of 4? It should be 0, 4, 8, basically 4 tables. 0, 4, 8, 12, 16 and so on. These are multiples of 4. Now for reflexive, I have to prove that it's an equivalence relation, right? For reflexive, it should be a minus a. Both a and b should have the same elements. A minus a is 0. 0 is a multiple of 4. 0 is a multiple of 4. Therefore, it's reflexive. So you can say R is reflexive because modulus of a minus a is 0 and 0 is a multiple of 4. That's all. Now, similarly, symmetric, right? For symmetric, it should be if a minus b is multiple of 4, then b minus a should also be multiple of 4, right? Now, obviously, right? So the numbers are reversed. So when you subtract, you will get the same number because there is modulus here. So if I say 4 minus, say, if I take 4 minus 0, I'll get 4, which is a multiple of 4. Then if I take 0 minus 4 is modulus of minus 4. Modulus of minus 4 is plus 4. So both the answers are same, even though you reverse the numbers, right? Therefore, you can say relation is symmetric because modulus of a minus b is multiple of 4 implies that modulus of b minus a is multiple of 4. That's all. You have to put this. It is symmetric. Relation is symmetric because a minus b is multiple of 4. This implies that b minus a is multiple of 4. Now we look at transitive. For transitive, modulus of a minus b should be multiple of 4, and if modulus of b minus c is multiple of 4, this implies that a minus c is also multiple of 4. Now take an example, right? If I take a as 0, b as 4 and c as 8. Now if I take modulus of a minus b, I'll get 0 minus 4, which is modulus of minus 4, which is 4. Now I'll take b minus c case, that is 4 minus 8, which is minus 4, which is 4. Now I'll take a minus c case, which is a is 0 minus c is 8, which is minus 8 and 8. Now if you notice, all these three are multiples of 4, right? So it's always true. Whenever you see that a minus b and b minus c are multiples of some number, a minus c also will be multiple of that same number, right? It's always true. So therefore it is transitive. So you can write R is transitive as modulus of a minus b is multiple of 4 and modulus of b minus c is multiple of 4 implies that modulus of a minus c is also multiple of 4. Now since the relation is reflexive, symmetric and transitive, we call this relation as equivalence relation. Now we'll go to the second case. A is equal to b. Relation is A is equal to B. Now for reflexive, what is it? It should be A comma A should belong to R. In place of B, I have put A itself. So can I say A is equal to A, right? A is equal to A, correct? So since A is equal to A, we can say it is reflexive. That's all. It is reflexive as A is equal to A, and this belongs to R. And this is for every element A belonging to set A. We have been given set A. Now we'll see symmetric. For symmetric, A comma B belongs to R implies that B comma A belongs to R. This is simple, right? A is equal to B implies that B is equal to A. Straightforward. So we can say R is symmetric because A is equal to B implies that B is equal to A. Now we'll see transitive. Transitive is A comma B combination, B comma C combination, and A comma C combination. So here in first combination, relation is A is equal to B. Second combination, B is equal to C. Third combination, A is equal to C. Now, if A is equal to B and B is equal to C, obviously A is equal to C because all are equal here. This means that all are equal. A is equal to B is equal to C. All three are equal. Therefore, it's transitive. So, I can say it is transitive because A is equal to B and B is equal to C implies that A is equal to C. The relation is reflexive, symmetric, and transitive. This is also an equivalence relation. Now, the second part of the question is find the set of all the elements related to 1 in each case. In both of these cases, you have to find elements related to 1. For the first case, we'll have to find the related elements which are related to 1. Right? Now, what is the relation for the first case? A minus B should be a multiple of 4. Right? This is the relation. So now, when you say the element should be related to 1, means one of the elements, right? You have A comma B, right? One of the elements should be 1, right? That's when you say that these two elements are related, right? That's when you say that these two elements are related. Now, the relationship is given here. It should be a multiple of 4, right? So, for it to be a multiple of 4, when you subtract A and B, you should get multiples of 4. So, it can be 0, 4, 8, 12 and so on. Now, what should be the numbers, right? The set is having numbers from 0, 1 to 12. Now, what can be those numbers, right? Which can give a multiple of 4 and one of the elements is 1. So, it can be 5, 1. It can be 9, 1. It can be 1, 1, right? 3 combinations are there. 1, 1 is 0, 9, 1 is 8, which is a multiple of 4, and 5, 1 is, when you subtract, you will get 4, which is again a multiple of 4. You cannot take number greater than 12 because a set does not have number greater than 12, right? So, therefore, set of related elements. So, you have to write set of related elements are 5, 9 and 1. These are the set of elements which are related to 1. So, 5, 9, 1 are the elements which are related to 1. Now, let's look at second case, right? Second relation. Here the relation is A is equal to B and you should find the set of elements related to 1. So, one of the elements should be 1, right? What is the other element? Here A is equal to B. A is equal to B means the other element is also 1, right? Other element is also 1. That's when you say A is equal to B. So, 1, 1. So, what is the set? Set is 1 only because only 1 is related to 1 here. Only 1 is related to 1 here. That satisfies this relation A is equal to B. So, this is the answer.